is a classic type of a GMAT question, comes up in different forms. Bob expects to spend a total of $9, so he's thinking about buying a certain amount at a certain price. And if you read the rest of the question, it's about the amounts he will get at a different price. So I'm going to define two quantities. P is going to be the price, dollar per pound, price of pasta. And then quantity, I'm going to call that Q. This is in pounds. And just keeping those variables distinct so I can visualize. So $9, if he's buying Q pounds, this is what he originally had planned for. And then the price was salad was 20 cents more per pound. So the actual price was P plus 0.2. And he ended up buying half pound less. So Q minus half. And he still spent $9. So this is our system equation. Now, if you were to solve for example, we're looking for how much did Bob spend per pound for the salad. So we're looking for this new price. You could eliminate Q by substituting. You'll end up with a quadratic equation and you can solve it. Maybe I'll do that here as well, but it's a lot of work. And it's actually easier to use the answer choices in this scenario. But obviously, you need to have the equations in place. So it's a little bit of a trial and error. And maybe we start with choice C. But the other thing you have to remember is that the answer choices are P plus 0.2. So the way you have to, so that's what makes it also a little harder. So P is 1.7. So then this would be 1.9 times Q minus half. It needs to be 9. And then that 1.7 times Q. And you'll see generally when I'm dealing with these answer choices, when I see 1.7, it doesn't go wholly into this. So those answer choices I typically don't use because in my experience, the numbers are so that these divisions are nice. So that's something that I've learned. If I do 1.8, then P will be 1.6. And again, okay, it's a little bit better. But I'm going to first start with the easiest one. So let me see if I do 2. In this case, P would be 1.8. So now we're getting some whole numbers. Q is 5. And then I have to check, do I satisfy this other equation? Actually, no, I have to go back to that one, which is 2 times 5 minus 0.5. Is that equal to, this is 0.5. Is that equal to 9? And you'll see 2 times 4.5 is indeed 9. So the answer is actually E. And P here is 1.8. So let me just write down the answer. So 1.8 times 5 is 9. And then P plus 0.2 times 5 minus 0.5, which is 2 times 4.5 is also 9. So the answer is E. But as I said, because it's a little bit trial and error in the exam, I mean, I understand that this can be stressful, especially with these numbers, 1.85, 1.95. At least I feel the stress of kind of doing these computations under pressure. Sometimes I'll make mistakes. But with these types of questions, my experience looking at, I mean, I've at least seen 5 or 10 of these over the years, that plugging in is the best way. Of course, if this was a data sufficiency, we kind of know it will be sufficient. But that's what I recommend. Now, you could certainly do the algebra, and let me see how quickly I can do, because it is still work. So Q minus half is equal to, let me see if I'm going to make this 1/5, if that's going to be better. And then I multiply both sides by 10, and then I'm going to multiply the first one with 5, just trying to keep everything whole number, and the second one by 2. And then we have PQ, so I'm going to distribute. Yeah, I think this will be work. This is maybe a good example where you don't want to do this. PQ is 90, so that's 90. This drops out, so I get 5P is equal to 2Q minus 1, and I really focus on P, so Q is 9 over P. So 18 over p minus 1, multiply both sides by p. 5p squared plus p minus 18 is 0. 5 times 18 is 90. Two numbers are going to be 10 and 9. And then 5p, p plus 2 minus 9, p plus 2. Then I factor out the p plus 2. P can't be negative, so that doesn't give me a solution. That p gives me 1.8. Obviously, 1.8 isn't the answer choices. That's an A for that particular reason. You always want to go back and read the question, how much did Bob spend per pound, meaning in his actual scenario, which was that. And that gives me 2. So, I mean, I think it's more work in my personal opinion, and I've seen this in distance rate type of questions as well. You always end up with this kind of a quadratic setup, and it does take time. But I'll let you kind of play with this, but just kind of, have a method in place for future when you see these variations in the exam, and just stick with, what you're comfortable. I mean, honestly, this is what I have ended up choosing over the years, although originally I was approaching things in the algebraic way. So it's about choosing a method that is faster. So to summarize, the answer is E.